Good morning, my dear students. So, in the last class, uh, if you recall, we have dealt rib shortening effect in two hinge arches. So, the rib shortening happens to be due to the reason uh, by development of normal thrust due to the loads uh, will cause the rib shortening, and the rib shortening is going to increase the horizontal thrust value developed at the springing point. This h is going to increase because I mean to say the h denominator value is going to increase, and h will reduce. This is the expression to be used for deriving or finding out a value of horizontal thrust for evaluating the rib shortening effect. Okay, so the denominator is going to be added with this value, integral cos square theta ds by a. Okay, right, now let us see the what is tied arch. This is another type of arch where we have not enlisted, but still, what does it mean? Tied arch means what? So if you can see the diagram, you can very well know that if the arch is provided with a tie, what this is called is a tie, is a tie member. Okay, so you better know what is meant by a tie from your earlier studies. Like if I make you to recall, like if you go to the arches, I mean to say trusses, if you can recall, you have your ties and struts. Okay, strut and tie model we call. So what is meant by a tie is a tension member when you talk about the arches, right? So strut is a compression member, right? So tie means it is purely a tension member. Means uh, uh, in a tie we will have only tensile force. That is what is meant by tie. Okay. So if you want to provide a tie, so what is the purpose of providing this tie, and how this is going to influence the internal forces developed in the arch? This is all our discussion. Okay. So right, if you can see, we have a change in support system also. See, support A is as usual hinge. Support B we have provided with a roller. If you can observe that we have provided a roller. Okay. So here the purpose of providing one of the supports, either A or B, with roller is to facilitate to tie to be in action. See, if you provide two hinges at the bottom, I mean, say at the springing points, and you provide a tie, there is no point in providing a tie because tie will never come into action. When the tie will come into action, when the supports will try to move away, the tie will try to hold them. Okay, the pulling effect, right? That is what is shown by the arrows here. So what the tie is doing to the support. That is what is this arrow. Okay, what the tie is doing here, tie is holding the support because of what? See, if you load this arch by some load, okay, if you load it by some loads, let us imagine that you have applied some loads on this arch. So what is going to happen? This arch is going to deform, right? So imagine that this is going to deform this manner, right? Why so? Because see, one end you have hinge, and it can never move in horizontal and vertical direction. So the other support is a roller. So there is a possibility of moving in this direction, and the vertical movement is arrested. Only horizontal movement is now given free, left free. So that's why this will try to move away because of this loads. So when you don't provide a tie, what happens? The arch is going to become to have deformation, and that we don't expect. Okay, we don't want that to happen. So what you need then? So to have stability to the arch, so you need something there to hold it. Okay, if it is hinge, this becomes a regular problem. So hinge at A, hinge at B, it is just a regular problem. So now when you provide a tie, what is happening? So the one that is provided is roller. So where you can have the arch stability by providing a tie member. So the stability is achieved through this tie member. So what this tie will do? So the uh, the deformation of the arch is minimized, and once the arch is deformed by the amount of the delta that tie can expand, and the arch will become stable. Okay, so this member is like your a bar. Okay, okay, so there is a force acting on this bar, so we expect some elongation. So after that elongation, the bar is going to be stable and it will not elongate further. So once it reaches its final value of delta starting from 0, and this roller will not move at all. So it will move by an amount of delta, and that is equal to the elongation of the tie. Okay, so this delta what is provided here is going to be the elongation value of the tie also. So if you don't have a tie, what happens? As you load it, and the arch is going to deform further and it is going to collapse. Okay, so that is a problem. So to stop that movement of roller B, we have provided a tie here. Okay, so this is what is the purpose of tie here, and that is why we call this arch as tied arch. Okay, right. So now the force developed at A and at B uh, because of this tie is like this. The arrows that are shown here at A and B, they are the forces acting on A. That means hinge at A and at B. Okay, they are the forces, right? So if you separate the tie member, what tie is what is going on for the tie? If you look at tie, so tie is being pulled. Okay, so because the supports are would like to move outward, the supports would like to move outward, so they pull the tie. The supports will pull the tie. What the tie will do? reverse action. The tie will try to hold the supports in position. Okay, so that's why this is called tie. You can see clearly that the force developed on this tie member is a tensile force. Okay, H, horizontal force, right? So this is uh, the purpose of what is meant by tied arch. So the stability of the arch is achieved by providing a tie where you have one hinge and one roller for the arch, supported by one hinge and one roller. So if it is there is no tie provided in the arch, like for that case, you will have two hinges, right? So if you want to have a roller for the arch, then tie shall be provided, right? Let us see what is the effect of this tie, provision of tie in the arch. Okay, maybe what is the effect of this tie provision in no, and how it is different from the regular arch, and uh, how the internal forces are changed. Okay, right. So as usual, we will have strain energy to be calculated, which is integral mx square ds by 2 ei, strain energy due to bending. And then mx we are going to write in terms of m dash minus hy, where m dash is beam moment, means nothing but due to vertical loads only, right? So this is already a non-content. Now let's come to this. So we were using dou u by dou h is equal to 0 as the basic equation that you should remember. And this is what is a change now. What is a change? You see, so dou u by dou h was 0 for an arch having uh, two supports as hinges, because the span of the arch will never change. Okay, though you apply loads, the uh, the distance between the two hinges is fixed. Okay, because the hinges will not move in horizontal direction. Now what, the dou u by dou h is not equal to 0, because you have some uh, change in length in the direction, in the span of the arch. uh, in the span of the arch there is a change. Okay, so that is what is this. So now your Castigliano's theorem, dou u by dou p is equal to delta, is appearing here. This is what we have studied when you talk about Castigliano's theorems. So dou u by dou p is equal to delta, means the strain energy in any member, if it is partially derivated with the load, you get the deformation in that direction. Okay, this is what is uh, discussion on happened on the Castigliano's theorem. That is what you are looking at now. So here the load is the redundant that is taken is H. Load is because it is an indeterminate structure, so that's why we are talking about redundant. So H is a redundant, and this is going to be delta in that direction. Okay, so this is what is the value, and y and delta, you know that the force acting here is tensile force. So delta is like axial load. So delta from axial load is it is like PL by AE. Delta is equal to PL by AE, if it is P, and this is also very well known formula for estimating delta in axially loaded members. Is this that you are using it right from your fundamental study in mechanics. Okay, so PL by AE is the delta. So where P is H, horizontal thrust. Why negative sign is provided here? Because you see the delta is, or the moment of the support is towards the right hand side. Okay, whereas the force is acting to the left hand side. Okay, so means what? The work done here is negative. The displacement is towards one direction and the force is acting to the other direction. Okay, that's why there is a negative work done. Okay, so PL by A. So applying that equation, so why this equation has come? So in place of dou U by dou H is equal to 0, okay, where delta is equal to 0 if it is uh, a regular arch with two hinges. Now here it is delta is not 0 because you have provided a tie member. That tie member is going to elongate. Okay, that elongation is appearing here, right? So where u is equal to integral mx square ds by 2 ei, substitute it from the strain energy formula. So that if you simplify further, let me clear that for our having clarity in that equation. Okay, right. So just simple partial derivative. So mx square here. So 2 times mx is again m dash minus hy, and partially derivating the term inside the brace is m dash minus hy is minus y. Okay, so ds by 2 ei, and this 2 and this 2 gets cancelled. Okay, so what you have here is this will become m dash into minus y, so minus m dash y ds by ei, and minus of minus plus integral h into y square ds by ei is equal to minus hl by ae. Okay, so this is what is the right hand side, and you know why this right hand side is appearing. This is because of this tie. Okay, right. Why negative sign is provided is because the work done here is negative, though the force is acting towards left, and the moment of that point is towards right hand side. Okay, right. Now you combine the terms having h to one side. Okay, so what you have here is, if you take this term to the right hand side, this term to the right hand side, and send this to left hand side, so what you have h common, so this will become plus. So h into h you can take it out, integral y square ds by ei, l by ae plus l by ae in the denominator. Numerator is as usual as earlier. Okay, so the change in the expression for evaluating h is l by ae is added to the denominator. Okay, so this is what you have. What you can say about this is, so in case of delta is equal to f l by ae. Okay, So this L by AE multiplier is applying here. Okay, so what is this? Delta divided by F is equal to L by AE. Okay, so what is this? When F is equal to 1 and delta is equal to L by AE. So when you apply a unit force, the deformation is equal to L by AE. So this is what we call flexibility value. Okay, flexibility value. This you will be getting in the last unit of this topic, essay 2, structural analysis 2. You have uh, the last unit of syllabus on this term. Okay, so flexibility, that I try to write it here. Okay, so this is flexibility, L by A. Right. So what is the effect of this, or how this tied arch is different from the regular arch? Let us see. All other are same. Your span, load, rise, everything is same except that one of the support is changed from hinge to roller, and you provide a tie. Okay, what is a tie? If you are asked to define tie, what is a tie? In arches, particularly in arches, a member provided at the springing points level uh, and tying in between A and B. That means a member provided to tie the springing points. That is what is a tie member in two hinged arch. Okay, so what, and that is named as tied arch. Okay, right. So if the denominator you are adding something, so denominator value is, entire denominator value is going to increase, right? So this total denominator value is going to increase, and what happens to h will reduce. So when h reduces, you can see it here, when h reduces, what happens? Mx value increases. That is what is the change in uh, the tied arch, between tied arch and the regular arch. Okay, so when compared to the conventional arch, I mean to say a two hinged arch, the tied arch will have more bending moment than the two hinged arch. Okay, the reason behind that is the denominator is added by value of flexibility, and that value is going to reduce horizontal thrust. Because of reduction in horizontal thrust, bending moment is going to increase, okay, in the arch, and similarly the bending stresses increases likewise. Okay, so this is how what we and this, whatever it is, whatever may be the value of L by AE, it is ultimately is going to be added, whatever may be, maybe plus some 0.00 something, anything is going to increase this denominator value. Okay, so this is what is the effect of the tie member when you provide in the arch. So bending moment is going to uh, increase. Okay, right? Okay, thank you all.